Rosen. Well, I know we're both beyond use. Don't make no.
Hello and welcome to the concepts video on logarithmic properties. So in previous videos we've already learned some properties of logs. So this is what we've learned already. So properties of logs, and then we're going to add to our list today. Okay, so properties of logs that we've already learned, those ones include the following. So we already have the inverse properties of logs and exponentials. So inverse properties are, we have the log one, so where log base b of b to the x power is simply equal to x, because these kind of cancel out each of their effects, the exponential part and the log part, right? So we have this inverse property as well as this other one where we have b raised to a power which is log base b of x. So again, the log and the exponential kind of cancel out and we just get x. Alrighty? So those are the inverse properties of logs. We also have learned the exponential property of logs. And what does that one mean? That is that log base b of a to the r, we can always take this exponent on the inside and move it out to the front as a coefficient. So then we just get this is equal to r times log base b of a. Okay, so we know that exponential property. And we also know one other one. We already learned the change of base property. Change of base. And this one says when you have log base b of a, we can always kind of split it up into a quotient and say that, well, we can make a new base, log base c of a, and then over log base c of b instead. Okay, so you can always change your base for your logs. Alrighty, so now let's get started on the new properties that we're going to learn. So let's say new properties of logs. Okay, so we're going to add a little bit to our list here. So the first one is going to be called the sum of logs. Okay, so sum of logs. So sum indicates that we're going to be adding something, and indeed we are. We're going to be adding log base b of a plus log base b of c, and this is going to be equal to log base b of a times c. Okay, so that's the sum property of logs. It's really useful in some contexts when we're trying to solve equations involving logarithms and things. So basically just says when you're adding two logs or two logarithms with the same base, you can always just kind of multiply or take the product of whatever's inside of them. So like a and c for this example here. Okay? So there's also the difference of logs property. Difference of logs. Okay, and then this one's a little bit different because we're going to have now a difference, right? So log base b of a minus log base b of c. This is a completely different example, okay, or a different property, right? So when you have a minus sign in between, that kind of means the same thing as saying, okay, well, that's like if we were to have, I'll just write down the rule here and then I'll explain why this is true. Okay, so this is like saying log base b of a over c. And the reasoning behind this is basically the difference of logs property. It's basically just kind of like a rephrasing of the sum of logs. It's a specific case. When we have, let's say we're looking at the left side, okay? So let's say we have log base b of a, right? And then minus is actually technically the same thing as plus a negative, right? So it's like we have a negative 1 in front of this log base b of c. And as we know from the exponential property, we can always move this guy back on, like going backwards using the property. We take the coefficient and stick it onto the c as an exponent. So this transforms into log base b of a plus log base b of c to the negative 1. Okay? And c to the negative 1, that just means the reciprocal, right? So now we have log base b of a plus log base b of 1 over c, and then see how we have this positive sign, or this plus sign in the middle, right, to add. So this basically just turns us back into the sum of logs property up here, right? So we have log base b of something plus log base b of something else is just equal to log base b of that something times something else, right? So a times c. So in this case, this would just transform into something that looks like that. Okay, and that's where the difference of logs property comes from. You don't have to know the whole derivation but it's good to have a background in how the property was derived. Alrighty, so let's do a quick example using the sum and difference, possibly, sum and difference properties of logs. So we're going to write this whole expression here as a single logarithm, okay? So as a single logarithm just means that at the end, we only want to see one log written, okay? Not three of them. So let's look at these first two. Let's deal with this first. So we have log base 3 of 5 plus log base 3 of 8. So the first thing we notice is that we have the same base, that's really good because now we have a lot of things to work with, right? So this is kind of like our A in the previous formula for the sum of logs, and this is like our C, okay? And B is like our 3. You don't have to like actually give them labels, like variable names or anything. I'm just saying in relation to the property that we learned, that's what, those are the positions in which our 5, 8, and 3 are in, okay? So according to the sum of logs property, we have that this plus log base 3 of 8 should be equal to, because we have the same base on our logarithm, log base 3 of 5 times 8, right? So when we do this, we get log base 3 of 40, okay? So that was just combining these two logs, okay? So now we have this, and then minus this guy, okay? So log base 3 of 40 minus log base 3 of 2, and this one looks a little bit different because we have that minus sign, so this means we're going to use the difference of logs property, okay? So that just says, okay, so this is going to be equal now to log base 3 of the first thing, so 40 minus, and because there's that minus sign, that means we're going to divide instead of multiply, and then a 2 on the bottom, okay? And then you just do algebra to simplify that, and that becomes a 20 inside, so our ultimate answer, the simplification is going to be log base 3 of 20.